Welcome to the session on simple harmonic motion. In this session, we are going to understand for an object which is executing simple harmonic motion, what is the relation between the displacement, velocity, and acceleration at different points and also at different times for a given cycle of simple harmonic motion. And we will be using the graphs to understand, and also I will be drawing a schematic representation so that you remember easily what are the minimum and maximum values at the mean and the endpoints. So I'm going to make use of the graphs like the ones shown on the right hand side for displacement, velocity, and acceleration. And it is highly recommended that you please go through my first session in which I have described what is a simple harmonic motion along with basic terms and what are the equations for displacement, velocity, and acceleration. Let's start. So let's first understand the graph of the displacement given by x equals to a sine omega t. And the graph of that I have drawn on the right hand side. How to draw the graph using the equation I've explained in my previous session. In this session, we are going to analyze the displacement over different positions and also at different times. So let's quickly recap. We have a particle we have an object which is executing simple harmonic motion, and we are considering only the one cycle of it, which has got the central position or the point as O, and the object is moving between the points A and B. And how it is moving is the first quarter or the first leg or the first step you can call is step number 1, where it is moving from O to A. And in step number 2, it is moving from A to O. And in step number 3, it is moving from point O to B. And in step number 4, it is moving from point B to O. So O is conveniently taken as a reference or the origin, and A and B are the extreme points. So let's analyze the graph for the displacement. So when the object is moving in step number 1 from time t equal to 0 to time t equal to 1t over 4, that is 1/4 of the time period. Time period is the time taken to complete one cycle of oscillation or SHM. So we see that in the first leg or in the first step, the displacement goes on increasing. The displacement goes on increasing as per the sine curve. And at t equals to t over 4, the displacement at point A becomes the maximum, and it is given by displacement equal to A, positive A. In step number 2, the object moves from point A to the point O, as per the graph shown by the sine curve. And we see that as it moves towards point O, the displacement goes on reducing. And at point O, at the time t equals to 2t over 4 or t over 2, which is half the time period, the displacement becomes 0. Yeah. So the minimum displacement that we see at point O is 0. Now, in step number 3, the object moves from O to B as per the curve shown. We see that the displacement goes on increasing, but this time it is increasing, of course, in absolute number, but it is in the negative direction. Yeah. And at point B, the displacement becomes the maximum in the negative direction, given by x equals to minus a. And this happens at time period t equals to 3/4 of t, okay, or 3/4 of the time period. And in step number 4, the object is moving from point B to O. And from the graph, we see that the displacement goes on reducing from the maximum value. It approaches to the minimum value, and then it finally becomes 0 at the time t equals to 4t over 4, which is nothing but t, which is the time period for one cycle of SHM. So if I summarize, the minimum displacement is 0, and it happens at the central point or midpoint uh, given by O, yeah, and it happens at time t equal to 0, time t equal to t by 2, and at time t equal to t. And the maximum displacement is to be seen in two ways. The positive maximum displacement happens at time t equal to t over 4, and the value is given by x equals to a, which is the amplitude. So it's x equals to positive a, and the maximum amplitude in the negative direction happens at time t equal to 3t over 4 at the point B, and it is given by x equals to negative a. So over here, it is important to mention that please do not get confused between the two letters A. This letter A indicates the point or the position, yeah, and this italic letter A refers to the amplitude. So please ensure that you have the correct understanding. Let's now understand the velocity, which is given by v, or also represented as x dot. Sometimes some books will also write it as x dash, which is the time derivative of the displacement. And as I've shown in my previous video, it is given by omega a cos omega t. Yeah, so given this is the equation for the velocity, we try to understand the behavior at different points and also at different times. So for the first part of the SHM, we see that when time t equals to 0, the velocity is the maximum, which is given by x equals to, which is given by v equals to omega a. And as the object moves from point O to point A, the velocity goes on reducing, and it eventually becomes 0 at the point A when the time is t equals to 1t over 4. Yeah. So this is the minimum velocity that happens at the endpoint A. And when the object moves from point A to O, we see that the velocity goes on increasing as it moves towards the point O, and it becomes maximum in the negative direction at point O. Yeah. And it happens at time t equals to t over 2, and the velocity is given by Vmax equals to minus omega a. So that was about the part 2. Now in part 3, when the object is moving from the point O to point B, we see that the velocity goes on reducing, and when it approaches the point B, the velocity becomes 0, and that happens at time t equal to 3t over 4. So the minimum velocity is also observed at point B, and the value of the minimum velocity is 0. And then in step number 4, we see that the velocity of the object when it moves from B to O, it goes on increasing, and it becomes maximum at point O, and that happens at time t equal to t, the time period. Yeah. So if I summarize, the maximum velocity happens at time t equal to 0 and also at time t equal to t. And that is, we are talking about positive maximum. And that is given by omega a. And the negative maximum for the velocity happens at time t equal to t over 2, and it happens over here at the point O, and the value is given by minus omega a. So that's the maximum velocity in the negative direction. And we see that velocity is the minimum equal to 0 at the point A given by time t equal to t over 4, and also at the point B given by the time t equal to 3t over 4. Now let's turn our attention to the acceleration, also given by the expression x double dot, and sometimes they also write as x double dash, so meaning double derivative of the displacement with respect to time. Okay, it is given by the expression minus omega square a sine omega t, and which can also be written as minus omega square x. So let's understand the graph of the acceleration. In step number 1, when the object is at position O, at time t equal to 0, the acceleration is 0. And that is the minimum value of the acceleration. And as the particle moves towards the point A, the acceleration goes on increasing, but in the negative direction. And at point A, that means at time t equals to 1t over 4, the acceleration is maximum in the negative direction, given by minus omega square a. Okay, in step number 2, when the object is moving from point A to O, we see that the acceleration goes on reducing, and at time t equal to t by 2, at the point O, the acceleration becomes 0. And in step number 3, when the object is moving from point O to B, we see that the acceleration goes on increasing. At point B, given by time t equal to 3t over 4, the acceleration becomes maximum, given by positive omega square a. And finally, in step number 4, when the object is moving from point B to O, we see that the acceleration goes on decreasing, and at point O, given by time t equal to t, the time period, the acceleration becomes 0. If we have to summarize, we see that the value of the acceleration is positive maximum at point O, which happens at time t equal to 3t over 4, and it is negative maximum at point A, given at t equal to 1t over 4, and the value of the minimum value of acceleration is 0, and it happens at the point O at time t equal to 0, then again at time t equal to t over 2, and then again at time t equal to t. So to summarize for acceleration, the minimum value of acceleration is 0, and it happens at time t equal to 0, point O, and at time t equal to t by 2 at point O again, and at time t equal to t, point O again. And the maximum value of acceleration on the positive side happens at time t equal to 3t over 4 at the point B. And the minimum and the maximum value of acceleration in the negative direction happens at time t equal to t over 4 at point A. Let's now try to understand the relation between the displacement and the velocity in simple harmonic motion by utilizing the concept of slope of the curve. So as explained previously, we have the curve for the displacement given by this graph, and then we also have the curve for the velocity given by this graph. Now, on the sine curve for the displacement, if I take 3 points given by, let's say, for example, line 1 in blue and line 2 in green and line 3 in red. So let's say we talk about the first point. So let's consider this point P on the displacement time graph. And at point P, if I draw a tangent, which is given by the line L1, and I see what is the angle it makes with the x direction. So I see that the angle will be close to, let's say, roughly 45 degree. Yeah. And if I take tan 45, so slope of the line L1 at the point P, slope at point P will be equal to tan 45, and we know that tan 45 degree is equal to 1. And that's exactly we get this point, let's say, let me call it as P dash, on the velocity time graph will be the point P dash will be representing the slope of the displacement time graph at point P. So there is a equivalence relation between P dash and P. So P dash on the velocity time graph is actually representing the slope of the curve at point P for the displacement time graph. So similarly, if we take, let's say, another point Q on the line L2, and if I see the slope of that line, if I have to find the slope of that line, so I have to see what angle it makes with the horizontal line or the x-axis. So in my case, let's say I observed it to be 27 degrees roughly. Yeah. And if I take slope of the tangent at the point Q, so slope at the point Q will be equal to tan 27 degree. So this is which is found to be equal to roughly 0.51. Yeah. And if I see the similar point on the velocity time graph, maybe I can call it as Q dash. And if I measure the length, this length, I see that this is indeed coming to be roughly 0.51. So there is an equivalence between the point Q dash and Q, wherein Q dash represents the slope of the tangent at the point Q on the displacement time graph, wherein this length of the point, wherein the point Q dash represents the slope, wherein the point Q dash on the velocity time graph represents the slope of the tangent L2 at the point Q on the displacement time graph. So now you must have got some idea, and we can extend the same logic for the line L3 in red. And let's say we consider the point R, this point as R. So if we see the slope of the tangent at R, so what is the angle that the tangent makes with the horizontal direction or the x-axis? So that will be tan 0 degree, and tan 0 is, we know it is 0, and therefore the point r dash on the velocity time graph represents the slope of the tangent at point r on the displacement time graph. So earlier we have seen that velocity is the derivative of the displacement. Now we are able to analyze it with respect to the graph, that velocity at any time is actually representing the slope of the tangent on the xt graph at the same time, t. So that's a key takeaway from this. Velocity at any point on the vt graph is actually representing the slope of the tangent at the very same point at the same time t on the displacement time graph. Let's now apply the same logic to understand the relation between the velocity and the acceleration in SHM in terms of the slope of the curve. So we have the VT graph given as the cosine graph, and then we have the AT graph given as the inverted sine graph. Okay, and like before, I make 3 lines or tangents, so L1, L2, and L3 respectively. And I try to understand for the line L1 at this point, maybe I call it as P. Okay, I want to know what is the slope of the point. I want to know what is the slope of the tangent L1 at the point P. So slope of the tangent L1 at the point P will be equal to tan of the angle this line makes with the horizontal axis or x-axis, so which is 0 degree. So this will be tan 0 degree, which in turn will be 0. Now, if we see the corresponding point P dash in blue on the AT graph, so at P dash, we have the acceleration, which is actually observed to be 0. So we say that this is the acceleration at the point P dash. So the acceleration at point P dash is actually representing the slope of the tangent L1 at the point P on the VT graph. So let's extend the same logic. Let's say this time we take line L2 in green, and I consider the point Q. Yeah. So at the point Q, let's see what is the angle this tangent makes with the positive direction of x-axis. So this angle is represented by theta, and maybe I can write here, this theta is found to be roughly equal to minus 27 degree. Yeah. So if I apply the same logic, slope of the line L2 at the point Q will be equal to tan of the angle and angle in this case is minus 27 degree. And we know that tan minus theta is minus tan theta. So I can write this as minus tan 27 degrees, and which in turn is found to be close to minus 0.51. And if I see the corresponding point for Q on the AT graph, so this will be Q dash. And if I see this value, if I see the value of the acceleration at the point Q dash, it's close to minus 0.51. So I can write this as acceleration at the point Q dash. So extending the same logic, now I talk about the line L3, and let's see what is the angle that this L3 makes at the point, maybe I take it as R. So I see that this angle is roughly minus 45 degree. And now I'm going to apply the same logic. Slope of the line L3 at the point R should be equal to tan of the angle which it makes with the positive direction of x-axis, which in this case is minus 45 degrees. Tan of minus theta again is minus tan theta. So this will be minus tan 45 degrees. And we know that tan 45 is 1. So this will be negative 1. So if I see the corresponding point R dash on the AT graph, so it's given by this red point. And if I see the value, this will be negative 1 for the acceleration. So this I can safely write as acceleration at R dash. Okay. If I have to summarize, I can write the generic statement. Acceleration is equal to the slope of the tangent on VT graph at the same time t. So acceleration at any point t on the AT graph will match with the value of the slope of the tangent on the VT graph at the same time t. So that's a very important observation. Let's now have a consolidated look at the values of the displacement, velocity, and acceleration during the 4 quarters of a cycle of simple harmonic motion. So before we go deep dive into this, let me explain that we are talking about one central point or the midpoint O, and then the two extreme points represented by A and B. For the ease of reference only, we are assuming that the object is starting from O. The first quarter is motion from O to A, and the second quarter is back from A to O, and the third quarter of the motion is O to B, and the fourth and the final quarter of the motion is B to O. Important to mention that I could have considered any other cycle also. For example, I could have considered something like this. We have B, O, and A. I could have considered the object starting the motion at point B. It goes to point O and then moves from O to A, and then A to O, and then finally from O to B. It really doesn't matter what is the starting point as long as we have all the 4 quarters present in the cycle. So for ease of reference, I've considered this to be representing as one cycle. Nothing stops us from applying the same concepts for any other cycle. For example, could be represented by this or any other. Also important to mention regarding the direction. So I'm considering O to be at the origin, and then A towards the positive side or the right hand side, and point B towards the left hand side or the negative side. So whenever I draw for maybe any of the variables X, V, or A, if I'm drawing, also it is important to mention about the direction of the physical quantity. So displacement represented by blue, velocity represented by green, and acceleration represented by red. Any of them, if the arrow is pointing towards the right hand side, so it is applicable for any of them, displacement, velocity, or acceleration. If the arrow is pointing towards the right hand side, that means that physical quantity is positive. Okay. And if the arrow on any of these parameters or physical quantities is pointing towards the left hand side, that means it is representing negative. So let's start with the first quarter of the motion. So as the object is starting from the point O, we see that the displacement at this point will be 0. And as it moves towards the right hand side, we see through these blue arrows that the displacement keeps on increasing. Why? Because the position of the object goes further and further away from the midpoint, and the displacement, which is measured, which is the distance measured with respect to the point O, it will go on increasing in the magnitude. And we see that the displacement will be the maximum at the end point A. And the maximum displacement given by x max will be equal to amplitude. Okay, so plus A, it means displacement is in the positive direction. Now talking about the velocity. So velocity at the midpoint, it has some maximum value, as we will see subsequently. The velocity goes on reducing as it moves towards the point A. So if you see, the length of the line segments or arrow segments keep reducing till the point A. At the point A, the velocity is the lowest and it is equal to 0. So V minimum is equal to 0. Now, important to mention that the arrow for the velocity is still pointing in the right hand side. That means in this quarter of the cycle, the velocity is positive and it goes on reducing in the magnitude. Now, interesting case for the acceleration. So acceleration has some value at the center point, which is the minimum value, as we also see in the other quarter. Acceleration is always pointing towards the center, and therefore the direction of the acceleration will always be opposite to the direction of the displacement. So as we see, as the object moves towards the point A, the acceleration goes on increasing in magnitude, but the direction always remains towards the center, which means negative. Yeah. And the maximum value of the acceleration, A max, is given by minus omega square A. So important to remember the values at the extreme point A. Now, all this motion for the first quarter of SHM is taking a time t equal to t over 4. Now, let's understand the second quarter of the SHM when the object is moving from point A to O. Now, let's try to understand the second quarter motion on similar lines. So second quarter starts with time t equal to t over 4, and the object is moving from point A to point O. As it is moving from right to left, we see for the displacement is the maximum at this point, at the point A, and as it is moving towards the left-hand side, the displacement goes on reducing, and it keeps on reducing till the point O, where the displacement is again 0. Now talking about the velocity, the object starts from point O with the velocity 0, and as it moves towards left-hand side, the velocity keeps on increasing, and the velocity is the maximum at the center. Okay, and the maximum velocity is given by V max equals to minus omega times A. So the direction of the velocity is towards the left-hand side, which means it is negative. Now, talking about the acceleration, at the point A, when it started, it was having the maximum acceleration and given by minus omega square A, and as it moves towards the left-hand side, as we see by the length of the line segment or arrow segment, the length goes on reducing, which means acceleration goes on reducing. Okay, and which means that the acceleration at the point O has a minimum value given by 0. Acceleration is always pointing towards the center, and it is always opposite to the direction of the displacement, as you see clearly. Now, talking about the third quarter, when the object is moving from O to B, so we see that the displacement is 0 at this point, point O, and as it moves towards the left-hand side, the displacement, magnitude of the displacement is increasing till the point it reaches x equals to B, where the displacement is the maximum given by x max is equal to negative A, which is minus amplitude. So the direction of the displacement is towards the left-hand side, which means negative. Talking about the velocity, so velocity of the object is the maximum at the center point O, and it goes on reducing as it moves towards the left hand side, and finally at the point B, the velocity becomes 0, which is the minimum value of the velocity. Talking about the acceleration, as it moves from the point O to A, so at the point O, we had the 0 acceleration. And we see that the acceleration goes on increasing in magnitude, as it moves towards the left-hand side. The direction always keeps pointing towards the center. And since it is pointing towards the center, or the direction is pointing for the acceleration from left to right, acceleration will always be positive in this quarter. And we see that at the endpoint B, the maximum value of the acceleration is given by omega square A. So positive sign indicates that acceleration is pointing on the positive side. That means from left to right. And in terms of the time, we see that the third quarter started with time t equal to 2t over 4 and ended at the time t equal to 3t over 4. Now let's focus on the fourth and the final quarter of this cycle when the object is moving from point B to point O. So starting from point B, where the displacement is the maximum given by negative A, as it moves towards the center or towards the right hand side, the magnitude of the displacement goes on reducing, and finally when it reaches the point O, the displacement is again 0 given by x min equal to 0. Talking about the velocity in the fourth quarter, so we see that velocity starts increasing from minimum value 0. It starts increasing in magnitude. Finally, at the point O, it is the maximum and given by V max is equal to omega times A. The direction of the velocity is towards the right hand side and therefore positive. Okay. Now, talking about acceleration. Acceleration at the point B was omega square A, and as the object moves to the right hand side towards the point O, the magnitude of the acceleration goes on reducing till the point O when the acceleration is minimum and the minimum value of acceleration is 0. In this quarter also, we see that acceleration is always pointing towards the center, and the direction of acceleration is opposite to the direction of the displacement. So summarizing the picture, the key takeaways are: at the endpoint A, the value of the displacement will be maximum given by A, velocity will be minimum, value given by 0, and acceleration will be maximum given by minus omega square A. Similarly, at the endpoint B, the displacement will be maximum given by negative A, velocity will be minimum given by 0, and the acceleration will be maximum given by omega square A. At the point O, the value of the displacement will be 0, which is the minimum value of displacement, and the value of acceleration is minimum given by 0. If you see, it is also the same, x min equal to 0 and x min equal to and a min equal to 0. But talking about the Vmax at the midpoint or the center point, Vmax will be negative omega A if the object at the point O is moving towards left hand side, and Vmax at the point O will be given by omega A if the object is moving at the point O towards the right hand side. So one can also summarize the information as per the table below. It's very important to mention that you should be fully familiar with what the values will be at the endpoints and also at the center point. And it is also very good if you remember if the values are increasing or decreasing, and if they are positive or negative with respect to the direction from the center point O.